Hello and welcome back to another video in this Java tutorial series. In today's video, we are going to be discussing a continuation of methods in Java, and we're going to be taking a look at more the application side of things. And so how methods fit into a class file and how we can use them to help complete a task, as well as the ability to be able to start programming from the ground up. So building a class file from nothing up to some target goal. To get started here, we have this task.txt file that's going to explain the entire exercise, or all the parts of it that we are going to complete. And so I encourage you to go through and attempt to do this exercise here completely on your own, because that's the fastest way of learning anything, is through trial by error. And me just talking to you isn't going to actually get any of that information to stick. It's going to come from you putting in the effort. So I encourage you to go through and try and do this exercise by yourself. Now, the entire point of all of this isn't to be able to get you to be able to start from scratch and get to the end goal without any help. The goal of this lesson is more specifically to be able to look at certain problems and to be able to figure out what syntax goes with what. How do I put all of these little puzzle pieces together to be able to form these full methods that we can use to solve problems? So that's what I want you to kind of think about as you're going through this lesson. With that being said, I'm going to begin my breakdown of all the stuff that's going on here. And so the first thing that we have to do here is we have to define the class and the instance variables. So we're going to create a class named dishwasher. And in order to do that, we're going to go over to our dishwasher.java file. And remember that the name of your file has to match the name of your class. And so we're going to come over here and we're going to start out by, I'm going to list out the package. And it's going to be package, and then let's see, what would it be? Lesson by practice.exercise. It's going to automatically fill that in for you. If I come back here, I go lesson, and then it's going to fill this in for you. But I haven't really explained packages yet, so I'm just going to encourage you to do that. I may fill this in automatically here in this file, but the first thing that we're going to need to do here, outside of filling in the package here, is we're going to need to create a class. And so in order to do that, we're just going to list out class and then the name of the class. In this case, it's going to be dishwasher. And then we're going to put, oops, not those ones. We are going to put curly braces to denote all the code that runs with the class here, that goes with the class. So we're going to create a class named dishwasher, and then we're going to define the following instance variables. So we've got a string brand, so the brand of the dishwasher. So we'll start out by listing the instance variables, and we'll label these here. Oops, instance variables. And so we have string brand, and what are the other ones we have here? Boolean is running, and so this is a flag determining whether the dishwasher is currently running, and it says we're going to initialize it to false, and by initialize it to false, we just mean when we create an object, we're going to set the default value to false. And so we're going to take is running, and we're going to set it to a default value of false. False. Oops, and I have to list the type of container, so Boolean. And then int water consumption per cycle, the amount of water used per cycle measured in gallons, once again with a default value of 0. So int water consumption per cycle, int water consumption per cycle equals 0. And then we have one more variable, I believe, and that is double total energy used. And this is going to be the total energy used by the dishwasher up until some point, and it's going to be measured in kilowatt hours. The units aren't terribly important. This is more for us as programmers to be able to keep track of like calculations and like how things are going to work, but it's just more to give context to the thing we're programming. And then we're going to give it a default value of 0. So we're going to double total energy used, double total energy used, and give it a default value of 0. So that's going to set up our instance variables here. So that is task 1 completed. The next one that we have here is we're going to go through and we're going to create the constructor. And so to implement our goal is to implement a constructor that takes a string parameter for the brand of the dishwasher and analyzes the brand instance variable. And so we're going to start out by listing a constructor here, and remember that to do that, it's just the name of the class and then dishwasher, and then the parentheses indicating what information we want to take in, and and then your curly braces. And we said that we wanted to take in a string as a parameter. So this, remember that a parameter is just some piece of information that we want to send in when we call our constructor. And so we're going to label this it's going to be a string container that the information is going to get stored in, and it's going to be called brand. And remember that it wanted us to initialize the instance variable brand up here, and in order to separate out the brand up here, the instance variable, with the brand of this local container that's like specific to this dishwasher method, or this dishwasher constructor, we use the this keyword, and the this keyword refers to the instance variable version of brand instead of this brand. And so we go this dot brand equals brand. And so that should be everything we need here for our constructor. Then the next task we have here is to implement the print status method. So we're going to create a method that prints the current status of the dishwasher, including the brand of the dishwasher, whether the dishwasher is running, the water consumption per cycle, and the total energy used. So these are going to be the four things that our method here is going to have to print when we call it here. And I'm just going to give you a hint. If you were to do this on your own, you might have to come back and refactor this to be able to get the expected output down here. But this is going to be the format that our print statement is going to use. I'm going to put this over here, and I'm going to comment it all out. And so we're going to create a method called print, what was it? I believe print state or print status. And so it's going to print out the status of our dishwasher. And that's the goal or the task of this method. And so we're going to start out with the return type. In this case, we don't want to send any information out to another file, so we're going to leave it as void. And we're going to do print status is going to be the name of it. We don't need to pass in any information, so empty parentheses and then curly braces. And so within this, what we need to do is we need to go through and we need to print out this part right here. Oops. System.out sysout, and then we're going to put this in a string. Dishwasher brand, and then we're going to attach to this string the brand, the instance variable brand. And then we're going to come over here, we're going to do sysout again, and then is running, we're going to copy that string, is running, and then we're going to attach the value of whether it's running or not, is running, and then we're going to attach this string of how many gallons per cycle we are using. Oops. Put that in a string. And then plus water consumption per cycle plus this last part, so gallons per cycle. Put that in the string. And then we're going to come down here and do the last statement, which is total energy used. So put that in a string, total energy used plus total energy used plus, and then within a string, kilowatt hours. And so this, when we call this method, it's going to act on our dishwasher method and print out all of the relevant instance variables here, or all the relevant information to our dishwasher. Now what we're going to do here is we're going to go over to our main.java file to test our print status method here, just to ensure that it works. And so we're going to jump over here to main.java, and we're going to start by instantiating or creating our dishwasher object. And in order to do that, we have to store it in some container. So we're going to go dishwasher to list out the type of information that's going to be stored in our container. It's going to be a dishwasher container, and we're going to call it dishwasher. And within that container, we're going to store a dishwasher object. And so we're going to, in order to get a dishwasher object, we need to call the constructor to create a dishwasher object. And so we're going to do that by using the new keyword and then calling the constructor, which was the name of the class, and then whatever piece of information that we tied to, or that we said we'd pass in when we'd call the constructor. And in this case, we need to pass in the brand. I'm just going to use the brand Samsung. And then we're going to put our semicolon here at the end. And then we're going to go dishwasher.printStatus. And what this should do is it should print out the status of our dishwasher. So the dishwasher brand is Samsung, is running, is set to false. The current water consumption is 0 gallons per cycle, and the total energy used is 0.0 kilowatt hours. Now, to reiterate what is going on here for like the fifth time, I've explained this so many times in the last lesson, but I'm going to do it one more time here because this concept is so important to kind of get through your head and to understand. And so, what's going on here is we're creating a dishwasher container, and within that, we're storing a dishwasher object. That's not new. We've done this plenty of times so far. But the special part is once again here within our print status method. It's printing out the information specific to this dishwasher that we stored here in our dishwasher. And so the reason that all of this works together the way it does is because we need to remember that our dishwasher object that we create is synonymous to the containers that are like wrapped together to kind of represent this object. So the brands are our instance variables here. So like the brand is running water consumption and total energy used. These are all containers here that are wrapped together and they represent the dishwasher object. These four containers together and the dishwasher object that we call our methods from are one in the same. And so when we go through and we call the print status method down here, it's going to, once again, method is just a block of code that's going to run when we call it. So it's just going to run this code for our method. But it's going to have access to the brand is running water consumption per cycle and total energy used because we are calling this method from a specific object, a very specific object in memory with its own four unique containers of brand is running water consumption and total energy used. And so when we call this method on it, when this dishwasher object performs the print status action, because we are telling Java that, hey, it's this specific object that's calling this action, the method here, this action, should instinctively have access to all of the information tied to the object that is calling this method or this action. And so because when we created this dishwasher, because we define a dishwasher object as these four containers, brand is running water consumption per cycle, total energy used, because these are our object, and that's why we call them these instance variables. They're tied to what our object is. We can access those same containers that are tied to what this container fundamentally is here down in our method, because these are the same containers that are synonymous to the object that is calling the action. I would also like to make the distinction here. When I say it's the dishwasher object that's calling the print status method, technically it is the dishwasher container here that's calling the action here. But what Java does when it actually executes this is it uses the object stored within this container to call the print status method, and so that's why I refer to it the way that I do. It is technically the dishwasher container calling the methods, and because it's still a dishwasher, it knows that it's going to have the brand is running and all of that. And so Java's fine with me doing all of this stuff. It knows that it's going to have access to like this print status method because it knows that this dishwasher container is going to contain a dishwasher, but it is technically the container and not the object, but because of how Java runs it, I call it by the dishwasher object. That's what I call it. Now, continuing our task list here, we're going to go through and we're going to now implement our start method. And so the first thing we need to do is create a start method that sets the total energy used to 0 and sets is running to true. So this doesn't sound like we need to send any information into our method or send any information out. So we're going to have a void return type and empty parentheses when we create the method. So we're going to come down here and we'll list out void, and then we're going to list out the name of our method, which is start, and we're not going to send in any information, so empty. Curly braces, and then we're going to list out our instructions, which are to set the total energy used to 0 and set is running to true. So total energy used to 0 and is running equals true. And remember that, once again, just because of how I've just explained this with the print status method here, we do have access to these containers of the object that we'll be calling this start method. So when we call it from a dishwasher object, we come over here and we go dishwasher dot, and we call the name of our method, which was start, then, start. And if we call that, we have access to these instance variables that are stored here within our dishwasher object. So rightfully, we should be able to modify those, such as setting the total energy used to 0, and the instance variable is running to true instead of false here. So the next thing here on our task method is just to implement the stop method. And so we just need to create a stop method that sets is running to false. So this is the same as our start method, except it just doesn't do anything with the total energy used variable here. And so what we could do is we could actually just copy this and then reformat it. So go down here, paste. It's going to have errors because we have two methods that have the same name, so it wouldn't know which one to technically run. So we're going to rename the bottom one to the one we want. So stop, we're going to delete this one. Total energy is going to be set to 0. And instead of setting is running to true, we're going to set is running to false, because that's what the stop action should do. It should stop the dishwasher from running. Now, the next part that we're going to implement here, our implement calculate energy used method task here, is probably going to be the most complicated one of this exercise. And so you might want to pay a bit more attention. So we're going to go through and we're going to read what we need to do with this. So we need to implement the calculate energy used method. So this is the name of it. And it's going to take in some parameter called time in minutes that's going to get stored in a double container. And then we're going to create a method that calculates and returns the energy used based on the water consumption per cycle and the time the dishwasher has been running. And so we're going to do some calculation that uses the instance variable water consumption per cycle, as well as the time the dishwasher has been running, which we can assume is probably the time in minutes that we're getting passed in. So when this method is called, we're going to pass in the amount of time that the dishwasher has been running, and it's going to be stored in this time in minutes container here. And then we also have this bottom part here, which gives us a formula for calculating the total amount of energy used. And then at the end, we're going to have to return that total amount of energy used, which was indicated here by the returns word. So create a method that calculates and returns the energy used. So it's going to return the result of this calculation and send that information over to wherever that method was called in any of our files. And so to start here, we're going to come over here and we're going to come down here, and we're going to create a new method. And remember that we need to return this type of information, and so it's going to return the energy used. And we're just going to assume that the type of container, the type of information that we're going to return, is going to be of type double, because total energy used is stored in doubles, and we're calculating the amount of energy used. So we're gonna assume we're gonna send back a double representing the energy used. So we're going to start by listing the return type here, which is going to be double. And then we're going to have the name of our method, calculate energy used. So calculate energy used. And then we're going to put our parentheses in here. And this time we're not going to leave our parentheses empty, because we want to pass in the information for how long the dishwasher has been running for. And so we're going to go double time in minutes. And then we're going to put our curly braces indicating the set of instructions that are going to go with this method. And we are currently getting an error because we haven't returned a result of type double yet. So we haven't told Java what piece of information we're going to send out when this method is called yet. So we're going to need to do that at some point. So create a method that calculates and returns the energy. So we've created the method, and now we need to calculate and return the energy used based on water consumption per cycle and the time in the dishwasher. And so the calculation here is, we're actually just going to copy this just because it's formatted in the same way. But this is going to be what's going to get returned. So we're going to come over here and we're going to hit return. And so this is going to be the calculation. So it's going to take the water consumption per cycle that is currently set on our dishwasher object, and this is going to I'll just tell you now that this is going to be changed at some later point in our program by some other methods. And so say water consumption per cycle is set to like 3 gallons for like the pre-wash, or 5 gallons for the main wash cycle, then that's what this container would tell us about. the dishwasher object. And then we just have some calculation here, times 1.34, and then plus this random number times however long the dishwasher has been running in minutes. And then we're going to take whatever the result of this is, and we're going to return that to wherever this method is called. Now, to validate the results of our method here and making sure we're doing this all correctly, we can go over to our main.java file here to see the results of our method call. And so if we come over here, and what we can start by doing is creating a container to return or to store the results, because remember that this calculate energy used method returns a piece of information over to our other file or wherever this method is called. And so we come over here and we go dishwasher, or we need to create a container first. So we go double, and we'll just call the container just energy. And within that container, we'll store dishwasher dot calculate energy used, and we'll pass in like a value of 15. And so this would be the equivalent of having a dishwasher run for 15 minutes, and then it's going to perform that calculation, times a dishwasher whose default value for water consumption is currently set to 0, so this part's going to return 0, and it's going to take 15 times this value here, and that value is then going to be sent out over to this location, and it's going to be stored in the energy container. So if we go sysout, and we print out energy, we get the result of that calculation here. It is important to note here that when we call the method and it returns and it sends out some piece of information, it returns the information stored in there at that specific time. It's when this set of instructions is run, that is the value that gets stored inside of energy. It's not storing this expression. So if we were to change the state and we were to set like the what was it called, water consumption per cycle, if we were to set that for our dishwasher, so if we were to take dishwasher and we take the water consumption per cycle and we set that equal to some value that isn't the same value that was used in this initial calculation, the result doesn't change when we print out energy, because we don't store the result, or we don't store the calculation or like the way to perform the calculation. We store the exact number resulting from the calculations in our container called energy. And so even after changing the state of our dishwasher, changing the water consumption per cycle that is used when this calculation is run, we still get the same printout. So we still get 2.96, even though we change the state of our dishwasher. We can also take this, the calculation here, or the thing that's going to, or the method call that's going to return the result of our calculation. And instead of storing it in a container, we can also, once again, just print it out to the console here just by putting it directly in here, because this thing is going to return a double, and if we wrap a print statement around that double, it's going to print out that value. And so we run it again, and we still get the same result here. The next thing that we're going to need to do here in our task file here is to implement our pre-wash method. So it's going to be called pre-wash, and it's going to take in some piece of information called time running that's going to get stored in a double container. And what this piece of information is going to represent is the amount of time that our dishwasher is going to run the pre-wash cycle of our dishwasher. And so we also have two other steps here, which are setting the water consumption per cycle to 3 gallons, as well as calculating and adding the energy used to the pre-wash cycle to total energy used. And so what this is going to look like is it's going to require us to alter the water consumption per cycle of the dishwasher we are calling the method on, as well as altering the total energy used instance variable of our dishwasher by increasing it by whatever amount of energy was used, whatever amount of energy was used during this pre-wash cycle. And so if we come over to our dishwasher.java file, we're going to start out by creating our method. And so our description didn't tell us of sending any information anywhere else, so we're going to have a void return type. And we are going to name it pre-wash. And then we're going to put our parentheses, and it told us that we're going to take in a piece of information here called double time running. So we're going to copy that, time running, and then we're going to put our brackets here. And we have two tasks, and that is to set the water consumption per cycle to 3 gallons. So we're going to set the water consumption per cycle, the instance variable that's tied to the object, the dishwasher object that calls this method. In this case, it would be, so dishwasher dot pre-wash. We would be changing the value of the dishwasher that's calling this method here. And we need to set the water consumption per cycle to 3 gallons per cycle. Then we had one other task for this method, and that is to calculate and add the energy used during the pre-wash cycle to total energy used. And I said that the calculate energy used method was probably the most complicated thing that we're going to do in this file, and more what I meant by that was understanding its usage here in the file. Because we had that simple example over here where we printed out the energy used. But what we can also do is we can use this same method here within another method to calculate the energy used when we call the pre-wash method. And what I mean by this is we can come down to our pre-wash method here, and we can calculate how much energy is used in one of these cycles. And so we can take our calculate energy used, and we can pass in the time that our cycle here is going to run. And once again, we don't know the value that's stored in time running, the time running container that's getting passed in here, but we can program with the idea of what that information represents. And in this case, time running is representing the amount of time that the pre-wash cycle is running for. And then so that value will get passed up into our calculate energy used method, and whatever value stored in time running will then get passed into this time in minutes container here. And then we can perform the calculation, and it'll return that result down here. But the second part of our task here was not just calling the calculate energy method here. It was to actually calculate and add the energy used during the pre-wash cycle to total energy used. So if we come back over here, we can take our instance variable, total energy used, and we can update that value using the plus equal sign with the amount of energy used during our pre-wash cycle. And the reason this makes sense here is because after setting the water consumption per cycle to 3 gallons per minute, if we then perform that calculation here and we pass in the amount of time that our pre-wash method here is running, then when we perform this calculation, it's going to simulate essentially the amount of energy used by our pre-wash cycle based off of the water consumption as well as the time in minutes. And so that total energy that would hypothetically be used by this pre-wash method would then be returned at this point and then updated, and would then update the total energy used instance variable. And this would be the instance variable that would be tied to the dishwasher object that would call it. Now what we're going to do here is we're going to walk through all the steps tied to what's going on in this program. And we start over here in our main method. And so Java is going to go through and it's going to look for the main method, and then it's going to run the set of instructions that come here with our main method. And it's going to do that from top down. And so we start up here and we start by creating this dishwasher container called dishwasher, and we create a new dishwasher object calling our dishwasher constructor and store it here within this dishwasher container. And then we come down here and we call our pre-wash method, passing in a value of 10 to or on our dishwasher object here. And so what this is going to do is it's going to start a cascade of different calls that are going to change different pieces of information about our dishwasher. And it's going to carry out all of the tasks and everything related to the pre-wash method. And so remember that because a method was just a set of instructions, to be able to carry out some action, or just a block of code that would be run when it was called, it's just going to go over to the pre-wash method and going to run the code associated with this method here. And so over here in our pre-wash method, we now have this value of time running storing the value of 10, because this is what we passed into our method call. So because remember that these parentheses dictate, hey, what information are we going to send into our method this is where we're sending in that information, and this is the container that's going to be storing that information. So every time we now use the container time running here within this method, it's going to be a placeholder for the value 10. That's the value it's going to store. So now the next step that we have here is setting the water consumption to 3. And like I've explained many times before, the reason that we can do this is because a dishwasher object, the thing that we created and stored in our dishwasher container, is the exact same thing as the amalgamation of the 4 instance variables, or like the combination of these 4 instance variables. These 4 variables and a dishwasher object are in essence the exact same thing. And so when we have a dishwasher object calling this action, then, or performing this action, then it makes sense that these actions that are being performed by a dishwasher should be able to know about the information tied to the dishwasher that is calling this method. It kind of just makes sense. If you are performing an action, then like the action should have knowledge about the thing performing the action, basically. And so we go through and we set the water consumption variable tied to this specific dishwasher object to the value of 3. And then we come down to the next part, and we go through and we take the total energy used instance variable that is tied to our dishwasher object, and we increase it using the plus equal sign by the amount of energy used by our pre-wash cycle. And so we're going to then basically make another call to another method, our calculate energy used method. And what this looks like is anytime we see what is called a nested method, or what I mean by nested method is just a method within inside of a method. So we have a pre-wash method here, and then we have a call to a method here, so that you would consider that a nested method because it is nested within another method. What we have here is a nested method that is the equivalent of taking our dishwasher object and now calling that calculate energy method using that, it is going to take the dishwasher object that it was initially calling our pre-wash method, and it is now going to call the calculate energy used method that we have down here. So it's going to use the same object that is calling this pre-wash method to call this calculate energy used method. And that's just how Java works. It allows us to do one of these things, and it's one of the great utilities or abilities that Java gives us to carry out our tasks here. And so that's going to trigger the calculate energy used method here to be run. And so it's going to then run this block of code here. But first we're going to have to pass in some piece of information, which in this case is we can pass, instead of passing in a direct value, we could also pass in a container. And when Java runs this, it's just going to pass in the value stored inside of this container to this other container. So it's just going to take our time running container and pass the value that's stored in there over to our time in minutes container. And so because we made this pre-wash call over here, storing a value of 10 in our time running container, when we pass this time running container, the value stored inside of here, over into our time in minutes container, this is now going to store the value of 10 as well. And so now it's going to run the instructed code that comes along with the calculate energy used method, and in this case it's going to send back this piece of information here. And because this is still the same dishwasher object that is calling this calculate energy used method, we have access to the same instance variables that we had here in our pre-wash method. And so now, because we set the water consumption per cycle to 3 before we called this method down here in our pre-wash, now this instance variable is going to, or this container is going to hold the value of 3 when we perform this calculation. So it's going to do 3 times 1.34 plus 0.153 times the time in minutes, and remember that it's just handing off the value here stored in the time running container to the value, or to the time in minutes container. So this is going to still hold the value 10, so it's going to do 10 times 0.153, and then add that to whatever this result is of 3 times 1.34. And then because we have the return keyword and we had the statement that we were going to send back a piece of information that could be represented as a double, it's going to send this information back, the result of this, which I know is going to be 5.5 because I've already run this method here and I've calculated that. But it's going to send back this value of 5.5, and it's going to now store that value or increase the total energy used container by whatever this thing returned here. And so basically, every time we see a method call, it's going to go through and it's going to run the set of instructions related to that method call before it resumes what was happening. So because, remember, like here, we started up here, we set the water consumption to 3, and then we increased the total energy used here by the amount returned from this method here. Whenever we make a method call like this, it's going to stop where it currently is, and it's going to go into this nested part, and it's going to run all of the code related to that method call, or that nested code, and then it's going to come back and it's going to resume back where it left off. So it started here, it left this part of the code to go to our calculate energy used method, and then it came back down here to then store the result of this method here in our total energy used container. And so that's going to now update the total energy used by our dishwasher object over here in our main file. And then it's going to go through and it's going to finish any other set of instructions here that we have in our main method. So if I come down here and I call dishwasher.printStatus, what we can see now is that after calling this pre-wash method, we now have a total energy used of 5.55 kilowatts. Now, the next thing that we're going to go through and do is if we come back over to our task.txt file, or our task.txt file here, and we go over here and we read this out, it wants us to implement a main wash method. So this would be the part of a dishwashing cycle that would come after the pre-wash, where you actually go through and you actually apply the soap and you run the water across everything, and you get all the stuff off the dishes. And so what we're required to do within this method is pass in a piece of information representing how long we want our main wash method to last. And then we have the second part here, which sets the water consumption per cycle to 0. Oops, sorry. It sets our water consumption per cycle to 5 here. And then it's going to go and do the same thing that we did in our pre-wash. So essentially what it's going to look like is the same thing as our pre-wash method, except instead of setting the water consumption per cycle to 3, it's going to set it to 5, because the main wash is going to use much more water than our pre-wash. So we're going to come down here, we're going to write out void, we're going to go main wash, and then in here we're going to pass in, or we're going to write out the type of information that we want to pass in, and the name of the container that we want to store that information in. And we're going to call that container time running. Oops. Time running. Struggling here, my gosh. And then we're going to do curly braces, and that's going to set up our method body here. And we're going to instead set the water consumption per cycle to 5. And we're going to go down and we're going to update the total energy used by our dishwasher here with the amount of energy used by our dishwasher. And in order to calculate how much energy we would use, we are going to once again call our calculate energy used and pass in the time that this method was run for, and the thing that represents that information is this time running container. And so if we come back over here, what we could then do is we could come down here and we can run dishwasher.mainwash, and in this one we would instead pass in like a value of 40 minutes, and we should see our total energy used go from 5.55 kilowatt hours up to this 18.37 kilowatt hours, and that's what we see happen here. And that's because after running our pre-wash and updating the total energy used to 5.5 kilowatt hours, we go through and we add to the total energy used any of, or the amount of energy that would be used by this main wash method. and so we get this change in energy usage. One other thing that I should point out here is the reason that we went from 5.5 to 18.37 kilowatt hours in terms of energy usage. And so the first time we make this method call here with calculate energy used, we only use 5.5, but in this case we use like 13 something kilowatt hours, or like 12.8, 12.9 kilowatt hours worth of energy. So what's going on here? Why are these two things why are these increasing the energy by different amounts? And it's because our code is set up to be used in a general format. We are not programming with the specific numbers in mind. We're programming with the containers. And so what's happening here with the calculate energy used, even though these are calling the same methods, they are using different pieces of data. And so in this first example, the state of our dishwasher has the brand set to Samsung, is currently still set to false. We'll need to address that at some later point on. But the water consumption per cycle of our dishwasher when we're running the pre-wash is set to 3. But when we're running the main wash here, the water consumption per cycle is set to 5. And when we go and we call this chunk of code related to the calculate energy method, this calculate energy method uses relevant information stored within the dishwasher. And because the water consumption per cycle was set to 3 in the first like wash cycle, and in our second one it's set to 5, this is going to change the results of this method. It's going to return a different value. In addition to that, the value that's passed in for time in minutes in the first case is passed in as a value of 10 when it's called here in the pre-wash method, when we pass in the time running container here, which stores the value 10 and then passes it over here to our time in minutes container. So the first time we call this method here, it has a value of 10 for time in minutes. But in the second case, via the same principle, now time in minutes is now storing 40 minutes instead. And so in the second case, we've now changed the state of the dishwasher, so when we go and we perform this calculation, it's using different numbers, and thus we get different results added to the total amount of energy used in these two cases. At this point, we just have two more methods to add here from our task.txt file. And so the first thing that we have here is our dry method, and this is going to do the exact same thing as our main wash and our pre-wash method, except it's going to set the water consumption per cycle to 0, because during the drying stage of our dishwasher, we shouldn't be using any water. We're drying off the dishes, and so we want to ensure that that value is set to 0, so that when we perform the calculation, this thing here returns 0, because you take the water consumption per cycle, which should be set to 0, times 1.34, which returns the value 0. So it should only be based on how long you've run the cycle for. And so if we come down here and we go and we set void dry, and we pass in the time running, oops, and we come down here and we go water consumption per cycle equals 0, and we do the same thing that we did in the other cases where we update the total energy used using our method there. And we come over here and we update that so that these match. Technically, so these things are they're just the names of containers, so we can actually technically rename these things to be anything we want. They also don't interfere with each other because they are tied to different methods, so Java doesn't care, because this container here is only local to this method. So it's when you rename it the same thing in these other cases, it's able to tell the difference between the container that we've labeled as time running up here and the labeled time running that we have down here, the container labeled time running that we have down here. Because essentially you can think of it as like a file system. When Java goes to fetch the value set in this time running container, it's going to go our main.prewash or dishwasher.prewash.time running to access this container, whereas the time running down here would be dishwasher.mainwash.time running, and so it'd have this preface there that would tell it which one it's referring to. But this one I'm just going to go back and rename with a capital one, so it just follows the naming convention and everything. But technically these can just be anything that we want it to be, as long as it doesn't use any strange symbols or anything like that, and it would still carry out the correct function, because once again, these are just containers, and we program with containers. The information inside of these would remain the same no matter what we name them. It would just be harder for another programmer to look at your code and figure out what's going on if these things aren't named well. And so now we've gone through here, and the other reason that we set the water consumption per cycle to 0, and we didn't just leave it empty. If we would have commented this out and we were like, oh, because we didn't set the water consumption per cycle to anything, well then, oh, it should just use a default value of 0. But it doesn't do that, and it's because when we call this main wash method over here on our dishwasher object, it changes the state of the dishwasher. It goes through and it sets the value stored within the water consumption per cycle container that is specific to this dishwasher object, and it sets that value here to, or sorry, they're the same value but in different methods. It sets this water consumption per cycle container here to the value of 5, and so the next time any methods make a call on that same object, if we were to come down here and we were to do dishwasher dot dry, if we were to do this with, I'm going to pass in a value of 30, and that's going to be the example value that we use here. If we run this without setting the water consumption per cycle to 0, then it's going to still have the water consumption per cycle set to 5, and so that's going to change what this calculate energy used method is going to return, because instead of water consumption per cycle being set to 0, it's being set to 5. And you might think, wait. I thought when we go up here in our instance variables and we set these things to default values, shouldn't this be what they default to, and they should only change when we call these methods? No, that's not how default values work. Default values specifically work on the fact that these are the default values that an object gets when we create them. Anything that we do to change the state at any point after we've gone and we've created the object permanently changes the state of that object, at least until you go through and you stop running the program and then you start it from scratch again. That would be the only thing that would change an object or its state. And so when we go through and we run each of these methods, each of these are affecting the current state of the dishwasher. And so if we come over here and we run this without the water consumption per cycle being set to 0, we get a higher number than we expected. And to prove that, if I come back over here and I set this to 0 and we run this, we come back over here and we run this again, we now get a lower number. And so the last thing that we have to do here is to come back over here and implement this last method. And this run full cycle method is everything that we've been working up to. It's supposed to be a method that represents being able to run or simulate an entire dishwasher cycle here on our dishwasher object. And so it's going to go through and it's going to call the start method, the start method. It's going to run each of the wash cycles, and then it's going to call the stop method. And so it should go through and fully simulate all the things that would be necessary to run a full cycle. And so if we come back over here, we can see this is going to be the name of our method. It's not going to take in any information, and if you go through this and you read it, it doesn't talk about sending any information outward, so it's going to have a void return type. So we're going to come down here, we're going to go void, and we're going to call it run full cycle, passing in no information, and we're going to list our method body here. And we're going to go through and simulate a full cycle by first calling the start method. So we're going to call the start method. And then we're going to go through and we're going to call the pre-wash method for 10 minutes. So we're going to go pre-wash. We're going to pass in a value of 10. Then we're going to run the main wash for 40 minutes. We're going to go main wash, and we're going to pass in the value of 40 minutes. Be careful here because it auto-filled this in with total energy used. This just doesn't, this isn't the behavior we want. This would use whatever kilowatt hours are stored in our dishwasher object after running the pre-wash method, and that would just lead to unexpected behavior. So make sure you're passing in the correct information. And then we come back over here and then we want to run the dry method here for 30 minutes. And so we come down here and we run the dry method for 30 minutes, and the last part is to run the stop method to set is running to false here. So we come down here, stop, and then we just put the semicolon at the end. So instead of going through and doing all the stuff that we've done here and running all of these pieces individually, we can now just call a single method called run full cycle, which will go through and it will run each of these individual methods here related to running a dishwasher cycle. So we can replace all of this just with dishwasher.run full cycle. And the benefit of doing something like this is if we want to carry out a full cycle, we just need this one simple statement that tells us what it would do. Versus if we were to do that for any other ones, we would have to go through and we would have to copy and paste these 3 lines of code every time we wanted to run a cycle. And this isn't very obvious what we're trying to do here. So it's much better just to use a method like this to represent our intent. And so say we wanted to run another one, we could just come down here and hit run full cycle again, and this is very obvious as to what we're doing here. So we can run full cycle, and the last thing that we have here is just to go through and create an object that stores the value Samsung, run the cycle, and then print status, which I already have done over here because this has been kind of how I've been explaining it, and I was using these objects here to help debug what was going on. But what we should get is this expected output down here. So if we run this and everything runs as intended, then we should have this same matching output down here as we do up here. And so dishwasher brand is set to Samsung, is running is set to false, current water consumption is set to 0 gallons per cycle, which should make sense because now that our dishwasher has stopped running, like it's finished the cycle, it shouldn't be using any water, and the total energy used by the end of our cycle is 22.96 kilowatt hours, which we see lines up with our calculation here. Now, I encourage you to go through and try kind of messing around with our dishwasher.java file, or our dishwasher class file here, and trying to figure out, hey, if I make this tweak here in this specific method, how is that going to affect the rest of my code? And if you can predict what's going to happen, then you're probably in a pretty good place. And I want you to kind of maybe try doing that and figuring out, hey, if I change any of these values up here, is that going to affect anything else? And I want you to go through and do that for kind of each of these methods to kind of make sure that you kind of understand what's going on here. But I'm going to cover a couple of these simple tweaks that we can make here, or a couple of things to test, and see if you kind of understand what's going on here. So the first thing that I'm going to test you here is if I come down here and I take our dishwasher object and we run another full cycle on our dishwasher, what is going to happen to the status? And so I'll first comment this out so you can see the results of this here. But if I have the total energy used as 22.96, what's going to happen if we run the full cycle method again? And so if I uncomment this and we run it again, what you'll notice here is we have the total energy used being still set to 22.96. Well, shouldn't this be increased to like 45 something kilowatt hours because we ran 2 full cycles? And the reason this doesn't happen is because this run full cycle method here has multiple components. It doesn't just run the cycles, it also has this start and this stop method that we defined in here. And so part of that start method is that it's going to go through and it's going to take the total energy used and it's going to set it equal to 0. And so even though we ran a full cycle, and if I were to even though we ran a full cycle, and at that point if we were to print the status, if we go through and we run another cycle, because part of running that cycle includes calling the start method here, it's going to go through and it's going to set the total energy used back to 0. And the reason we set this up was because we just wanted this variable to keep track of the amount of energy used per entire wash cycle. We didn't want to keep track of the total amount of energy used for the entire lifetime of the dishwasher, just how much was used by that specific cycle. And so that's the reason that we did this. And the result of that is that the total energy used, no matter how many times we run the full cycle method on our dishwasher object, will still store the same the same value here, because it's essentially going to basically just reset all of these values here back to their kind of like default states, and it's going to just run a cycle from scratch again, essentially, is what's going to happen here. I would also like to provide the reminder that, once again, anytime we see nested methods here in our composite method called run full cycle, and composite method is just the method which contains all of these nested methods here. And I'd like to remind you that when we call like the start method, the pre-wash method, the main wash method, dry and stop, it's the same thing as taking the dishwasher object that called the run full cycle method. If I just clean this up a little bit, it's the same thing as taking that exact same dishwasher object and calling these methods from that same object. And so when we call the start method is acting on the same object, the same dishwasher object that called the run full cycle method. So you can imagine it as being like dishwasher dot start or something like that. But we don't specify it here just because those are the syntax rules, or like the grammar rules of Java. We don't need to specify the name of a container, because that would lead to a bunch of issues. If we had to specify the names of containers, it would remove the general idea of a class file, because class files are supposed to represent the general idea of all the stuff that makes up an object. It shouldn't be tied to any one specific container. But Java is able to figure out that when we call the start method, this start method should be acting on the same object that called the run full cycle method. So these things all impact the same object. The other thing that I could demonstrate to you with this start method here and resetting it to the value 0 each time this is run is if I were just to comment it out and I were to run the run full cycle method each of the times now, we can see that now, because we don't call, or we don't set that value of 0 each time at the start of our start method, and thus the start of our run full cycle method, now we see that we do get that increase in total energy used, and so that would change the behavior of our method here. Alright, and so now the last thing that I want to kind of quiz you on here is what would happen to our program if we were to come down here and we were to swap this value of 40 and 30 in these two places. If we were to pass into our main wash method a value of 30 and into our dry method a value of 40. And before I do this, I'm going to first look at our initial output here. So if we run this, this is our initial output. So if we change these values to 30 and 40, what's going to happen to your program? And before I tell you, I want you to go through and figure out, hey, is this thing going to increase? Is it going to decrease? And I want you to kind of track down all the things that are going to happen when this program runs and when finally the print status method runs, to figure out how is our program going to change. And so if I run this, what we get is actually the same result. And this won't always, very rarely will this actually happen, but this happens because of the commutative property of addition. I'll explain that as we kind of go through here. And so basically, when we run this full cycle method, in both cases, when we swap these values, nothing else has changed here, and the stop method isn't going to affect it. So the only things that are changing are the values being added on in the main wash and the dry wash method. The only things that are being changed are the values being added on here when we're performing these calculations. And so in the first case, we call main wash when it was still at 40 minutes and the dry time was at 30 minutes. We come down here and we the orange here is the main wash, the blue one is when we go, and this is like the equivalent method, or all the code that would basically be run here when we call the dry method. And so basically, when we call the main wash, it's going to go down and it's going to set the water consumption here to 5, and then it's going to update the total energy used based off of our calculation. So then it's going to come up here and it's going to run our calculation based off of the water consumption per cycle that is currently set on our dishwasher, as well as the time in minutes that's being passed in here. And so if we look at this method and we look at the calculation that's being passed in, or the calculation that's being performed here. If we look at our main wash, total energy used is going to be updated with the sum of these two things. It's going to we're basically taking this part here, and this is going to be the value that's going to update our total energy used instance variable. And so the water consumption here has been set to 5 right before we've made this call to our energy used method. And so this part here is the first part is going to calculate out to 6.7. And now the second part here is going to calculate out to a value of 6.12 because we take remember that our time running here has been passed in as 40 minutes. And so when this gets passed over to our calculate energy used method, the value of 40 is then subsequently also passed into our time in minutes container, so the calculation is performed as 0.153 times 40, and so we get the result of 6.12. And so this result of 12.82 then is added to our total energy use. So 12.82 kilowatts have been used when we called the main wash method. In the second scenario here, what we have is the water consumption has been set to 0, and the time running is set to 30 minutes. And so we now add the total energy used the total energy used that will be updated by is 4.59 kilowatts here after we do the math, because water consumption is set to 0, so this part will calculate out to 0, which is this part of the formula, and the second part here will calculate out to 4.59 because time in minutes here, or time running, these will essentially end up being the same containers, but this part here will calculate out to 4.59. So that will then update the total energy used. But in the case that we swap the values 30 and 40 here in our main wash and our dry methods, what ends up happening here is that our water consumption when we go and we calculate the main wash is still the exact same. We haven't changed the first part of the equation, but we've changed the second. We're just now doing the same calculation we did down here, and we're calculating out the time in minutes now stored as 30 times 0.15. So we get the result of 4.59. And in the second case, when we run the dry method, remember these are both run in the same order. We both call the main wash method first, and then we call the dry method. When we call the dry method here in the second version after we've swapped these two numbers, when we come down here, water consumption is still set to 0, so the first part of the calculation is still 0, but the second part is now adding 40 times 0.153. This part here is now storing the value of 40 and so when we perform the calculation, when we add it down here, this value is now storing 6.12. And ultimately, what's happened is we've used the commutative rule of addition, where because in both of these cases, this is the addition of, or the total energy used is the addition of whatever was calculated in our pre-wash plus these two things plus these two things. You're adding up after the pre-wash. You're adding up 4 different things. In essence, what we're just doing is we're just swapping the order of addition. In this case, because the same calculation is performed, we're doing 30 times 0.153 and 40 times 0.153. We are just swapping the order that we do them. And so when we do the main wash method in the initial case here, we are first doing this calculation, but in the second case, this calculation is essentially, in essence, run second, just because of the swap in numbers. And so the order that these two things are added is just changed by swapping what values are passed in, but we ultimately end up with the same result. Now, it is really important to point out here that the only reason this happens is specifically because of the way that our formula works here. If this were any slightly different, if we were to take this and multiply the time in minutes times water consumption per cycle. Just because of some other math rules, you could kind of go through and try to figure out why this would be different. But if we were to do something like this, the result of swapping these two things would change the output of our thing, and we can actually test that. So if I run the base one here, we get 45, and now if I swap these and we do this one, now we get a result of 38. And so I more expected you to only figure out that they remain the same by tracking down everything that's going on here and figuring out, hey, what's going to happen here. But this is by no means guaranteed whatsoever. It's entirely dependent on our formula here, and anytime you are tracking down, trying to figure out what's going to happen if we make some change to our code, you should always go down, and you should never make assumptions about your code. You should always go down into your code and try and figure out, hey, what parts can this influence? If it can influence this, how is it going to influence it? And you're going to want to go through step by step and walk through your code here. Now, that is going to bring us to the end of the lesson here. I encourage you to kind of go through and try and maybe add some additional methods, add some additional functionality here. Maybe you wanted to run a shorter cycle or run a full cycle with shorter times, and so maybe you would take this method here and you would go through and you'd make all of these things shorter. Maybe you'd come up with something like that. But just I really want you to go through and kind of mess around with this and dig in and figure out what's going on, because this is the best time to do it, because as we keep going, things are going to keep getting more complicated, and if you don't understand kind of the building blocks of everything that we're doing, you're going to get left behind. But with that being said, I hope you enjoyed the rest of the night, and we'll see you in the next one. Peace.